Okay, looks like I'm streaming. So, just pulled together a YouTube playlist. So on my YouTube channel, which is youtube.com/Bangford, you should be able to find all of the videos that I've made on this New York City taxi Kaggle so far. There's a couple of the very short ones that I've made recently on Twitch that I'm not sure if I'm going to put those on there or not. But just to kind of, I think I'm really quite close to wrapping this up. So what I've done is I've run through my code. I've run through Maduri's code again. I've done it in Jupyter Lab, and this time I've done it with just 1 million rows, and I was really surprised at how quickly it ran. So if you use 10 million rows, not surprisingly it takes a lot longer, because it hangs on one of the data cleaning steps, then it hangs on the first model, then it hangs on the second model, and I think it takes, on 10 million it takes about an hour, I think, at least half an hour. On 1 million it seems to just whiz through in a few minutes. So that's the difference, working with different amounts of data. And I guess in the end I might go for 15 or 20 million just to get the best score that I can. But for now, what I'm interested in is comparing the success of 3 different models. So the random forest, the light GBM, and then XGBOOST. So let's see how those 3 fare against each other on 1 million on the same basis. So that's going to involve running the models, and 2 of them have already run and produced results. Run the 3rd model, then upload each of those to Kaggle and see. Obviously it will say something like, this is not your best score, but I think it'll give me a score, and then I'm going to put that in a spreadsheet. So that's the first thing. And the other thing, I'm going to try not to forget this. One person commented that somewhere in the data there's a step change in taxi pricing, and I think this means that if you throw away all the data before a certain point, you actually get a more predictive model. But I don't really know how to do that bit of EDA at the moment, but I'll try and we'll see how it goes. So streaming, 2 minutes. Right, so I should make a list. I need to make a list. So it's compare 3 models, and then remove, look at time trend, remove old data. Okay, so the next instruction is going to fail. And I'm hoping to show the process of solving this. So XGBoost doesn't exist. Now, what's this thing called? Conda. I can't remember what it's called. It's not Anaconda. Or is it? I need to check. I thought I was using Conda. Let's have another look. Yeah, it's the Anaconda prompt. So let's see. So we want to install XGBoost. Come on. Looks like some people are having problems. Conda install Anaconda Pi XGBoost. Let's try it. The following new packages will be installed. XGBoost. Looks like it might be. Good old Stack Overflow, eh? Well, let's see what happens when we run this. It works. I hope I've done that the right. I hope I've done that the right way. XGBoost core D matrix at this. Different number, but that's probably fine. Is it a different number? Yeah. Ooh. Right, so what have we done? We've imported XGBoost. We've created a training and test. Set the parameters. Oh, now this is interesting. So, max depth of 7. Let's go through each of these one at a time. Right, max depth. Maximum depth of a tree. Increasing this value will make the model more complex and more likely to overfit. 0 indicates no limit. Note that limit is required when grow policy is set of depth-wise. Range 0 to infinity. Max depth. ETA. 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 Hey! Step size shrinkage used in update to prevent overfitting. Who wrote this? This is the official HGB. Okay. Ha! ETA default is 0.3. And we've got an ETA of 1. Step size shrinkage. After each boosting step, we can directly get the weights of new features, and ETA shrinks the feature weights to make the boosting process more conservative. Range 0 to 1. So we're set at the maximum there. Silent. Silent. What is silent? General parameters. Parameters for tree booster. Additional parameters for dart booster. What is silent? Does that just mean that it doesn't show loads of stuff on the... I don't... Silent 1. So I'm going to just search XGBoost silent. Silent parameter. 1 indeed turns off a lot of information. We'll train until eval error. Okay. Okay. Silent 1. So is silent the opposite of verbose? Not sure, but it sounds like it's a similar thing. Silent 1. Objective reg linear. Let's have a look at all the different objectives. Objective. So you can do linear regression, logistic regression, binary logistic, and binary logitral. Ooh. You can also do GPU. Okay, so that there could be some interesting stuff we could do here. Eval metric. So this is going to give us a score. I think we're going to have our own evaluation metrics for validation data. A default metric will be assigned according to objective. RMSE for regression, an error for classification, mean average for precision, mean average precision for ranking. Users can add multiple evaluation metrics. RMSE is root mean square error. MAE is mean absolute error. Log loss is negative log likelihood. Error. Binary classification error rate. Error at T. air mirror, M-log, lots of different things. Okay. So I think from previous experience that this will give us our own score, and I think what that allows you to do is to tweak the parameters and keep running the model yourself without having to upload it to Kaggle and then have some idea of whether it's performing better. That's my story, and I'm sticking to it. Learning rate 0.05, number of rounds 50. So let's run that and set the parameters. So this is the bit that's going to take the longest. And that didn't take very long at all. So yet again we have a set of predictions, and we can see how, for example, our first method, assuming that they're in the same order, so the first method, which was random forest, so observation 0 has a prediction of 965. Then it has in the second method, which was light GBM, it has a prediction of £10.77. Dollars. And then it looks like it might be 964, 965. Ooh, now that's interesting. Interesting. So this method says 965, this method says 1077, and this method says 965, apparently. I like the way she's done this. So we now create something called submission XGB. There we are. Yeah. So this is like, so row 0, 965, row 0, 965, row 1, 984, row 1, completely different. These models don't have a clue. Right. So, I now think that we have 3 files, so we're on to the next stage. I'm going to mark it up on my thing. Compare 3 models. Right, that's what we've got to do next. Here they all are. So we've got submission 1. Right, so what I'm going to do, I'm going to cut all of those. Rename. Right, we're ready to go. So we're going to do the forest one first. Random forest 1 million rows. Make the submission. No free lunch, first in, first out. Jump to your position. Not an improvement, but we got a score, that's the important thing. Copy. Thank you. Oh, that's annoying. Undo. Undo. Pay special. Values. Keep going. Submit predictions. Upload. Light GBM. Open. Light GBM 1 million. Make submission. Something tells me this isn't your first CSV file. You take the artificial out of AI. 3.33861. We have a winner. One more. XGBOOST. I think, is that the worst? I can't remember. Yes, that's the worst. Undo. Okay, so our best on a comparable basis, light GBM 1 million 3.33. One thing I would like to try out, I noticed that the XGBOOST is only 50 rounds. Let's go and have a look at the parameters for the other thing. Light GBM doesn't have a number of rounds apparently. What is light GBM exactly? Microsoft. Which algorithm takes the crown? Light GBM versus XGBOOST? That's pretty much what we're doing. If you're an active member of the machine learning community, you must be aware of boosting machines and their capabilities. The development of boosting machines started from AdaBoost to today's XGBOOST. XGBOOST has become a de facto algorithm for winning competitions. Really? Simply because it is extremely powerful. But given lots and lots of data, even XGBOOST takes a long time to train. Enter light GBM. Many of you might not be familiar with the light gradient boosting, but you will be after reading this article. The most natural question that will come to your mind is why another boosting machine algorithm? Is it superior to XGBoost? Well, you very well must have guessed the answer, otherwise why would a topic deserve its own article? Light GBM is a fast, distributed, high-performance gradient boosting framework based on decision tree algorithm used for ranking, classification, and many other machine learning tasks. Okay, bit of homework. Right. So let's see what happens if we run 500 rounds. So we need to run this. And then this. Followed by this. And create a submission. So Maduri says, and that's a wrap. With the random forest code, I got a score of 3.39. Why do I get a worse score? Why would I get a worse score? My data is slightly different because I cleaned it. I changed something slightly. Okay, with the random forest I got a score of 3.39, which was in the top 20%. With LGBM I got a score of 3.37, which wasn't a great improvement, but helped me jump a couple of places up the leaderboard. And with XGBoost I got a 3.61, which is the worst of all my submissions. Maybe parameter tuning would help further. So somebody's written, I really appreciate your attention to details and thank you so much for sharing it here. I've used some of your points as is in my kernel for data cleansing. Personally, I feel that whoever makes use of the full training data will have a definite advantage over the others. Hansel. A few people have said that the kernel helped them to deal with date time before fitting the model. One thing that I was going to say is in R I'm used to, and this could just be the silent parameter, but in R when you run XGBoost I'm used to seeing it output you can set it so that it outputs every 5 and you see it working, so you have some idea of how it's progressing, which ain't happening here. So where are we? 32 minutes in. We've run it with 500 rounds, so we should have, so I'll go back to my PC, go back to my C drive, user, and there, submission XGB, cut that, go to Python, Kaggle, taxi, output, comparison, no, I need to drop it here first. Rename. So we've got XGB 50 and XGB 500. And what do the results look like? Still quite different results. Interesting. It's not 965 anymore for the first one. It seems to be tending towards the light GBM results, which is interesting because the light GBM is the best set. So my guess is that the 500 is going to help us here. Right. I need to close some of these because it's confusing for me. Submit. Upload. XGB 500 1 million. That's 500 iterations on 1 million rows. And I would say for an XGBoost 500 is not that many. Make submission. What? What? I've just moved up the leaderboard and I'm only using 1 million rows. Whoa! That's interesting. That's my best result. Whoa. Interesting. That's my best result on the whole competition. I can't believe it. And that takes me to 148. I wasn't expecting it to be my best I really wasn't. So where are we now? 148. Out of 571? You know what, I'm going to do it the other way around. 571, 148 equals that divided by that. Ooh, it's not in the top 20% anymore. Bah. I just remember that Midori had mentioned that her code, her initial code, with a score of, which we've got, so there was a point when, where is it now? There was a time when 3.37 was in the top 20%. I've now got 3.14, which is a great number to have, isn't it? 3.14 is about 26%. So the objective now is to get back into the top 20% using this approach. So I'm going to, I think I'm going to finish this live stream here and chuck this one on YouTube because it seems to have worked quite well.